The next lesson is going to be 13.3, which is quadratic inequalities. So if you still haven't watched 13.1 or 13.2, you're going to want to do those first because this is going to rely on some knowledge from those two lessons. So we're dealing with inequalities, but we don't have absolute values. We're dealing with things that will factor, quadratics that will factor. So your first step is going to be to get all of the terms in the quadratic to the left side so that you have 0 on the other side of the inequality. Once you have that, you're going to factor your quadratic, and then from there, you're going to basically have several intervals that you're going to test, and that will help you determine if it's an and or an or, and what is included in that interval. This one already has 0 on the other side, so I can just go ahead and start solving. So I'm going to start by factoring the quadratic. So I'm looking for factors. So -1 and -7 will multiply to give -7, but add up to -8. And then once I have these, I know they're not actually equal to these, but this is what we're going to use when we're dealing with testing our intervals. We're going to be testing with 1 and 7 on a number line. So you're going to make a number line, and you're going to place your two numbers on there. Now make sure you put these in chronological order, so smaller number has to go to the left, bigger number has to go to the right. And then each of these intervals you're going to be testing, remember this is like -infinity, this is a full number line. You're going to test values in each of these three sections to see if they would satisfy the inequality or not. And when I'm talking about the inequality, I'm talking about this inequality right here. Now you could also use this one. It's the same thing, it's equivalent, but it's easier to usually work with the factored one. For this one, I'm going to pick a number that is somewhere between -infinity and 1. So the easiest pick for me would be 0. So essentially I'm going to be plugging 0 in and testing to see if this is a true or false statement. So we end up with -1 times -7. Well, that's going to be +7. So +7 is greater than or equal to 0, so that's true. Now we're going to test this next interval here. So a number between 1 and 7, you have many picks, but I'm going to go ahead and pick 2. So we have 2 minus 1, and then 2 minus 7. So 2 minus 1 is 1 times a -5. -5 is not greater than 0, so this does not work. And then the last section you're going to check is this one right here. So a number between 7 and infinity, you can pick anything you want. I'm going to pick 10. Three. So that is true. 30 is greater than 0. So this interval also works. So as you can see, since we're excluding this section that exists between 1 and 7, that means this is going to be an or inequality. So x could be less than or equal to 1, or x can be greater than or equal to 7. And the reason I know there's an equal to is because of the inequality in the original question. To write this in interval notation, I use my number line, and I use square brackets because I know that 7 and 1 are included on their respective intervals. For example 2, you're going to want to get everything to one side of the inequality, the left side. So I'm going to subtract the 42 over. And then we know that when we're factoring a quadratic, we're going to need to make our a term, that's the term in front of the x squared, 1. And this one isn't 1, it's -1. So to deal with that, I can factor out a -1. But there is a consequence to doing that because now I'm dealing with a -1 on the outside. So what I can do is I can get rid of it by dividing both sides by a negative. But normally with an equal sign, it doesn't affect anything. But here, recall that when you divide by a negative, it's going to flip your inequality sign. So this is now going to flip the other direction, like that. So now I'm going to go ahead and factor. So factors of 42 that add up to 13 are going to be 6 and 7. And then I know that my testing intervals are going to be with -6 and -7. And remember, you got to put these in chronological order on the number line. Okay, so with this one, we're going to test a value that is less than -7, between -7 and -6, and then greater than -6. So each one of these 3 sections. All right, so I'm going to test something over here. I'm going to test -10. So this is going to be a negative times a negative, which is going to be a positive number that's greater than 0. Now a number between -7 and -6, the easiest one is going to be -6.5. So that's going to end up being -0.5 times 0.5, which is going to be a negative number, inevitably, and no negative number is going to be greater than 0, so this one is not true. And then lastly, let's check a number that's greater than -6, so we can just plug in 0. So if you plug in 0, you can probably already tell that's going to be the product of 6 and 7, which is of course greater than 0, so this does work. So this is another OR inequality. So we know that x is either less than or equal to -7, or x is greater than or equal to -6, and then we can rewrite it in interval notation as well. Now notice on this one I used parentheses here instead of square brackets, and that's because the inequality symbol doesn't have a line underneath it. So for the next one, I'm going to start by adding the 15 to the other side. Factor. And find the numbers I need to test for my number line. So I need to test a number that is less than -5, so -6. So that's going to be -3 times -1, which is going to be greater than 0. I'm going to test a number between -5 and -3, so -4. So that's going to be -1 times +1, which doesn't work because that's going to be a negative number. And then I'm going to test 0 for this last section here. And if you're familiar with it enough and you practiced, you don't need to test every single one by hand. You can probably just see this one is going to work because it's going to be 15. And then once you have that, you can go ahead and write it as a full inequality. So we have x is less than or equal to -5, or x is greater than or equal to -3. So as interval, it's going to look like this. And that's it. So it says, Zoe is designing her own regular wooden canvas for her artwork. She has 12 square feet of wood. She wants the width to be 1 foot longer than the height. Find the possible dimensions of Zoe's artwork for the canvas. So when we're talking about square feet, 12 is our area. I'm going to zoom in so you can see the work better. You can read it on your own paper. She wants the width to be 1 foot longer than the height of the canvas. So we know that our width is the height plus 1. And I know that when I'm dealing with a rectangular canvas, the area is going to be equal to the width times the height. So of course our height is h, and then our width is the height plus 1. So now we have one variable. And I know that this area is going to have to be less than or equal to 12 because that's how much square footage she has of wood. So the product of, remember this represents the width because it's one more than the height. And then of course this represents the actual height. So then from here we can just solve. And now we have a quadratic, so we can bring the 12 over to the other side. And factor. Just like that. So then from here, we're going to go ahead and get our testing values for the interval by setting each of these equal to 0. I'm going to make my number line. And now I'm going to test values into here. So if I plug in a -5, that's going to give me -1 times -8. So that's saying 8 is less than or equal to 0. That's not true. So this one doesn't work. So now I'm going to test a value, oops, I don't know what's happening. I'm going to test a value between -4 and 3. So I'm going to try 0. And that's going to work because that's going to give me -12. And then I'm going to test a value between 3 and positive infinity, so I don't know, 5 or 4 would work, either one, or any other number. So we get 9 times 2, which is of course not less than 0. So this is an and inequality, because the only time it's true is when it's between -4 and 3. So you could write it as what we would call a compound inequality, which is saying that the height is going to have to be somewhere between -4 and 3. Or you can write it as an interval. Both ends are brackets because of these right here having an equal sign underneath them. And let's just go back and check what the question asked for. It said, what is the possible dimensions? So if these are our possible dimensions for our height, we could go back and plug in and find the width as well, the possible dimensions for the width. So this right here is the height, which means for the width, I'm going to add 1 to each of those, which would be this for width. I just added 1 to each of these because that's what the rule is right here. Okay, so the next one you can go ahead and read. It's a velocity acceleration problem. You've seen these many times before when we did quadratics. The difference with this problem is we're going to be looking at it in terms of an inequality. So with this question, it says in relation to time, the equation of the height of the ball is given. So everything else in the question prior to this is just explaining where each of those values in that equation came from. And they want to know how long the ball is in the air. Well, I know that the ball is in the air anytime that my height is greater than 0. Remember, this represents height. So when this is greater than 0, we know that the ball is in the air, because when the height reaches 0, it's on the ground. So we're going to use this to solve. Now, the problem with this particular question is we're working with something that isn't going to factor, so we're likely going to have to use a quadratic formula or completing the square. Looks like here we're going to have to use quadratic formula. So, if you recall, x equals negative b plus or minus b squared minus 4ac all over 2a. And we're going to plug into that formula. Like that. And remember, this yields us two solutions, the plus and the minus. I'm going to get my calculator out. So we got 40 squared minus 4 times negative 16 times 3.5. And that gives me the square root of this very big number over negative 32. Let's see if this is a perfect square. Just test it. It is not. We can see if we can at least reduce it. Well, let's see what I can take out of it. So I just did some testing with the calculator, and I see that I can rewrite this as this. I don't know if 114 breaks down anymore. I'm gonna have to check that. I don't think so. No, I don't think so. So I just broke this root into two equivalent roots, because this one right here is going to simplify. So this gives me negative 40 plus or minus 4 radical 114. And then I can simplify this, of course, right? This I can take out and a 4 out of everything. So this becomes negative 10 plus or minus radical 114 over 8, negative 8. So now we would have to test these on the number line. So in order to do that, I'm going to get these as decimal approximations, the positive and the negative version. It's coming out to be a really, really small number. It'd be a really short amount of time to be in the air. But this would get rejected anyways, because that's negative. Okay, so let's say it was a minus 0.08 is what I'm getting. So with this particular question, if you think about how a quadratic looks, something like this is how this one's gonna look. Where this right here represents the y-intercept, and this is the other 0. But this portion right here is not actually included in the math that we're doing, because we can't have negative time. So it hits the ground right here at the other intercept, the positive one. So the ball is in the air for we didn't really have to test an interval here, because one of the values was negative, so it wasn't really necessary because there's only one amount of time that it touches the ground. So that's that one, and that's it.